Wormholes, particle physics, extra dimensions. Are the wonders of so-called reality really what they appear to be? Or do we exist in an elaborate hologram? Is our universe the result of random activity or the result of intelligent design? If a creator was involved, can we discover him through our perception of divine order? This is Into the Multiverse with Josh Peck.
Traveling through space and time at ludicrous speed, it's Into the Multiverse. I'm your host, Josh Peck. With me, again, as always, and happily so, my lovely, beautiful, still pregnant wife.
Yep.
This is just we're going to be every episode. Still pregnant.
Nothing's happening yet.
Yeah, and we'll just see where it goes. Now watch, knowing our luck, because we're recording some of these ahead of time, we'll forget about this episode, and like 2 years later, we'll finally put it out there.
And then I'll still be pregnant 2 years later.
Yeah. Or people will think that you got pregnant again, and the whole hype will start.
No.
How are you?
I'm great. I feel awesome. I had a wonderful appointment today. Baby's doing great.
Oh, good. Thank God.
Everything's good, yes.
And I want to thank all of you out there who have been praying for us over the whole new baby thing. This is our third child, but of course, as parents out there know, any child, there's going to be at least some stress that comes along and some worry that comes along with it. So we really do appreciate all of you guys who have been keeping us in prayer. And
definitely. And it's so hot here in Missouri.
Oh, yeah.
This is August right now when we're recording this. In the beginning of August. So it's hot, and I'm miserable because it's so hot.
It's been mid-90s, and it's not like a dry heat. It's a muggy, humid,
and it's walk outside your door and you can't breathe, like dog breathing in your face, hot.
Yeah, it's rough. But I would much rather take Missouri summers over Michigan winters
any day.
Yeah, we come from Michigan.
I've said that. I even posted it online. Even though it is miserable and muggy and humid, I will take this over sub-zero temperatures and 6 months of dark, depressing, snowy, 6 foot of snow.
Can't go outside, can't do anything.
Wind chill is negative 30 degrees. Yep. So you're
people die just trying to shovel their driveways.
Yeah, that happened
it's crazy.
2 years ago.
Yeah.
So I take this over anything.
Yeah, and plus with my hip replacement, I'm so paranoid about stepping on ice and slipping or something and like ripping my hip out of its socket or something like that. So I would rather be extra hot than have to worry about that. So I will happily accept that trade-off.
Yeah, I'm happy regardless.
Well, we forgot to do this in and I don't know the order that we're going to be airing these in, but in the quantum entanglement episode, which may or may not have aired, I don't know what order we're doing, but we forgot to mention right off the bat where people can find us online.
Oh yeah, we didn't do that.
We did not do that.
We just jumped into talking about computers.
Yeah, so I'm going to make you do it twice. No, I'm kidding.
Whatever.
Where can people find us online?
Okay, we are a YouTube channel as of right now. And we are on Roku. You can find us at youtube.com/Into the Multiverse. You can find us also on Roku under the Skywatch TV channel. Also, if you don't want to go straight to the YouTube site, you can just do another longer roundabout way, I guess. Go to the Skywatch TV homepage at skywatchtv.com. Scroll down. There will be a picture of Josh and I. You can click on it, and it will bring you right here.
Absolutely.
Yep.
Yes, that is where you can find us. So today we're going to be talking about quantum tunneling, which this is
so cool.
It is. It's sort of a new area of research for us. We've heard of it before, but we haven't really extensively looked into it until fairly recently. But yeah, it's fascinating. I mean, all the different facets of quantum tunneling, because I remember. I had heard that term before, but never really thought anything about it because I didn't know what it meant or how important it really was. But come to find out, not only is it how the sun shines, but it can even cause DNA mutations.
Yeah, we're going to get into that,
yeah, which is totally weird. Now, we could start with, I guess we can start with electrons, An electron is it's a particle that travels around an atomic nucleus. And basically what an atom is, I think a lot of times when we think of an atom, we might think of like a solid particle or something, but really what an atom is, you have the nucleus or the center of the atom, which is made up of protons and neutrons, which are made up of quarks, and various forces are involved. So you have the nucleus, and then you have one or more electrons, depending what type of atom it is, that basically orbit the nucleus. But even saying orbit is a little off, which we'll get into why.
They don't really just go like this, but they go like this and this.
Well,
and
there's a cloud. We'll get into that. But so when we talk about an atomic nucleus, or the plural atomic nuclei, because we're going to be talking a little bit. That's all it is. It's just the middle of an atom. It's just that the nucleus part of. It's like the yolk of an egg, and you could even think of the egg shell as what we will describe in a minute. The
cloud.
The probability cloud of the electron. All these just technical terms for really. I think an egg is a pretty good.
That's pretty good.
A pretty good example of
Never
what it
thought
is.
of an egg.
Yeah. So just think of atomic nucleus, that's the egg yolk, the electron where it might be in space, that's the eggshell. So we'll talk about the electron probability cloud in a moment, but first, I think a good analogy to think about what quantum tunneling actually is, or what the consequence of it is to imagine bouncing a tennis ball on a wall or on the table or something. You bounce it. A wall is better. We'll just say wall.
Yep.
It rhymes with ball. So bounce a tennis ball on the wall. See, now that I'm hearing myself say it, it sounds annoying. But I've started it, and I'm going to commit, and I'm going to own this thing.
You do it.
So imagine bouncing a tennis ball on a wall and catching it. Now you know pretty much 100% of the time it's going to bounce back.
That's how reality works.
That's how reality works. But actually, there is a very small statistical probability that the tennis ball will actually show up on the other side. Technically, I guess you could say going through the wall, but technically it's not. It's just showing up on the other side, or even embedded in the wall. Now, it's not breaking through the wall and going through it. It's just showing up there. Now, for something as big as a tennis ball to be able to do that, you would need more time than the universe is going to be alive to actually have that happen even once. But on a quantum scale with quantum particles, and quantum just means, for those of you who might be new to the show, the term quantum just means the smallest of the small.
Yes.
So for quantum particles, this actually happens pretty frequent by our standards. It's infrequent when you think about how many particles there are.
Yes.
But it actually does happen. That's
every day.
Yeah, every day, and that's what quantum tunneling is. It's a particle's ability, say an electron. We'll use that as an example. The electron's ability to essentially travel through a barrier that it shouldn't be able to travel through.
Right, and I can wrap my mind around this. It's not the same thing, but osmosis. You know, the soluble going into a less soluble, like traveling through a barrier. It's only because it can, but that's just how I relate the two.
Okay.
It's a little bit. It's not the same thing, but you can relate the two.
I don't know much about microbiology, but for those of you who are interested in that, maybe that analogy probably makes sense.
Yeah, exactly. It's just basically a molecule goes through another barrier and into a less soluble state from a higher soluble state. That's how I can relate the two, and I can wrap my mind around quantum tunneling. That's just from my medical background.
And that's how we know, that's how we have found out that I don't know what soluble means.
This is a science show. we're not getting into any anatomy, physiology, or any medicine.
Why? That's science. But anyway, so maybe that example will help some. It doesn't me, but I know nothing about microbiology.
I'm just throwing it out there for
I have to have,
anybody who understands medicine.
Oh, yeah,
I have
sure.
a medical background.
Yeah.
So
yeah, for that kind of stuff, I always either have to have you or Sharon Gilbert explain that stuff to me, because it's.
She knows much more than I do.
Yeah.
I never went that far, but
Well,
still.
yeah, I mean, between the two of you definitely know a lot more than I do, but about that. But yeah, so but essentially, it's the ability for a particle like an electron to travel. See, saying traveling through isn't exactly accurate, because it's not going through the barrier. It's just showing up on the other side. But just for lack of a better term, it's going through the barrier. Now
On a quantum scale.
On a quantum scale. Now the way this works is actually because the quantum world is based on probability. There's a principle called Heisenberg's uncertainty principle, which states that you can't know both the position and velocity of like an electron, of a particle. So you can't know where it is and how fast it's going at the same time. It's one or the other. So say you have an electron. You can't know where it is if you know how fast it's going. So what they've developed what's called an electron probability cloud, which is basically, around the center, here's where it might be, here's where it is most probable to be, around the edges, less probable that the electron's going to be here.
Doesn't mean it won't be there.
It doesn't mean it won't be, but there's less of a chance that it's going to be.
Yep.
And an example of this, I heard a good example online that says, say you leave your cat in the house and you go to work. The cat has a higher probability of being in its favorite sleeping spot, but it still could be in the kitchen eating. Maybe even less likely, it could have found its way into the wall or something. It could have dug through the plaster, and it's less likely that it's there, but it still could be. Now, even less likely than that is it could be outside of the house somehow.
Right.
Even if you lock your house, cats are weird; they can figure things out. But even if you lock your house, it could be outside of the house. So
we
that's
had a
sort
cat
of
that opened up the door. Remember?
Yeah. So that's sort of how this barrier thing works. Think of the cat as the electron and the barrier as the house. Now, when you have a probability cloud and that probability cloud approaches a barrier, most times the electron will just bounce off the barrier and go somewhere else.
That's usually what happens.
Exactly. But some of that probability cloud actually overlaps the barrier. So there's a chance that somehow, and we do not know how this works, no one does, but there's a chance that somehow that particle could be found on the other side of that barrier.
On this side of the barrier.
Even though it's impossible, even though it's a high energy barrier that the electron does not have enough energy to go through, somehow it could still happen. And this is what makes quantum tunneling so cool, because I've heard quantum mechanics explained as, being based in probabilities. And I always thought that was just due to our limited perception. We don't have instruments that can detect it. You can detect a particle enough to be able to tell where it is and how fast it's going. I thought it was always a human limit. I didn't think reality actually worked that way. Like I thought that if you could shrink yourself down small enough, like if you were Ant-Man or something, then you would be able to, you'd be able to know where stuff was and how fast it was going. But no, it actually is that way. Like reality is actually based on probabilities and not a set, definite thing. Now on the macro scale, it's basically set in laws, but still weird things can happen.
Yep, things happen.
It's really weird. Now we're going to talk about how the sun shines and what that has to do with quantum tunneling and all that after this.
Can you sing the blues with a heart full of joy? The answer is yes, because as you may know all too well, sometimes the joy that comes from accepting Jesus Christ only follows after you've been broken for good. Skywatch TV is proud to present the new CD by Joe Horn and Broken for Good, Right Where You Stand, featuring the dynamite lead track, Johnny. When you order this CD from the Skywatch TV store, you'll also receive the special Johnny Project DVD featuring a special one-on-one message of salvation and redemption from Pastor Bruce Beelan, who played the Johnny character in the Johnny video, as well as special commentary from writer-producer Joe Artis Horn and special Skywatch TV world premiere countdown programs that led up to the world premiere of the video of Johnny. You'll also receive the books Redeemed Unredeemable by Donna Howell of Broken for Good and John McTernan's When Jesus Sets You Free, You Are Free Indeed. 2 books that demonstrate that the love of God is never so far away that he can't find you right where you stand. You'll also get the acoustic instrumental album from Broken for Good's Stan Williams, featuring Celtic acoustic originals like Finger Dance, Celtic Walk, historical hymns like I Surrender All, and many more. Right Where You Stand by Joe Horn and Broken for Good is gutsy, full of passionate songs of faith and redemption like Talk to Jesus,
And talk to Jesus. And talk to
Begin Again,
To begin again,
Come All My Children,
come on, my children,
Right Light,
the right light
and many more.
is gonna set me free.
All of this together is a $75 value, but it's yours now for just $29.95 when you order the Joe Horn and Broken for Good CD Right Where You Stand from the Skywatch TV store. Order now by calling the number on your screen or log on to skywatchtvstore.com.
All right, welcome back to Into the Multiverse. We have ate up so much time just talking about
The probability.
our very first bullet point, and we have 2 more we'll see.
Okay.
But we can get into how the sun shines. I wrote down some notes here, so those at home are probably going to see me look down at my computer a lot. But again, this is still relatively new to us, so I want to make sure I'm explaining things correctly. Quantum tunneling actually causes the sun to shine. If quantum
Yes.
tunneling wasn't a real thing, and if reality it wasn't based on probabilities the way that it is, we would have no sun. It wouldn't be able to shine.
It would not shine.
Now, the sun uses what's called nuclear fusion
Yes.
to produce heat and light. And the way that works is you have 2 positively charged atomic nuclei. And again, atomic nuclei, plural of nucleus. The atomic nucleus is what we described before. Think of the yolk of an egg. Now, when we say that they're positively charged, think of a kitchen magnet. If you take 2 kitchen magnets, if they're on opposite ends, you can put them together and they'll
Yeah.
attract. But if you put them on the same end, they'll repel.
Yeah.
Well, it's essentially the same thing. When 2 particles are positively charged, they repel each other. There's an energy barrier there, just like between 2 kitchen magnets. For the sun to be able to work the way it does, those 2 positively charged particles must combine together. They have to fuse together. That's why they call it nuclear fusion. It's the fusion. Yeah, it's the fusion of 2 nucleus. 2 nuclei. So nuclear fusion. That's so it's not as complicated as it sounds.
No, it's not.
But they have to be able to fuse in order to release photons and release light, because in that fusion photons are released,
They're
and so you get
released.
energy and heat and light and all that. But our sun, technically, it's not hot enough to give these nuclei enough energy to get past that energy barrier. It would be like if you had 2 really strong magnets and like a baby try to push them together
Yeah.
or something. It's not strong enough to be able to do it. It's kind of like it's basically the same thing as that. Yet somehow it still happens, and it's because of quantum tunneling.
Yes.
Physically, this should be impossible.
That's why I believe it has something to do with a higher dimension.
Yes, and that's something that we should touch on too. Because how could something get around something without going through it or going around it?
And just showing up on the other side.
Exactly.
Again, you can use a flatland.
Flatland, perfect, a great example. And we've used the example of flatland prison in a sense. Like what would, and again, for those who aren't familiar with flatland, if this is your first time watching, it's just a theoretical, hypothetical, basically think of a 2-dimensional world. The inhabitants are called flatlanders. They don't have up or down, but they have all the other directions. So they have no concept of up or down. They're two-dimensional. Now, if a flatlander wanted to put another flatlander in prison, he would just have to create a circle around that flatlander and he couldn't get out. If I wanted to get him out of prison, I just lift him up into the third dimension and set him down next to it. To the flatlanders viewing this spectacle, the way that it would look is it would look like the flatlander just disappeared and then reappeared next to the prison. So I'm wondering if we're seeing something similar to that. If in a sense, these particles are escaping into higher dimensions and reappearing on the other
side of the barrier.
Right.
Yeah.
That's the only way that something like this, I think, could even be physically possible.
Yeah. And in a sense, and because we explained in another episode how photons are instantaneous.
Yeah.
And they are exchanging information instantaneously.
Instantaneously. Yeah.
Okay. Pregnancy brain.
Don't worry about it.
Couldn't think of the word.
No, I have pregnancy brain all the time.
I know you do. So in a way, it's like quantum tunneling. Yes, tunneling. Quantum tunneling, in a sense, is similar to quantum entanglement.
Yeah, because it's both at instantaneous speeds, which that's the weird thing too.
It's instantly on the other side, and then it's instantly back.
No time passes. And that's the weird thing too.
That's why I believe it's a higher dimension.
Yeah, that's the best explanation that I've heard or been able to come up with. I believe that somehow they're accessing higher dimensions to do this. Now, actually, strangely enough, quantum tunneling can cause DNA mutation.
Yes.
This is a whole thing that we're going to have to go super fast through, but I wrote a blog recently about this. If you go to joshpeckdisclosure.blogspot.com, there's more information. Just look at the mystery. I think I called it Mystery of Quantum Tunneling. But look that up. Basically, quantum tunneling, if that happens within a cell, if one proton jumps to what's called a potential well or something, quantum tunnels through this barrier into where another proton is, and there's two protons there. Then that DNA divides or replicates, that it causes a mutation in that DNA. And actually, there are leading studies now that believe that might be what causes some cancers, but even just aging. Even just aging or things degrading might be caused by quantum tunneling. So, of course, we got to talking.
Yes.
And we wondered, maybe is that part of the curse? Because we believe that when Adam and Eve sinned, that's essentially when entropy came into play.
Yeah,
things started
entropy
degrading and
sin,
dying, and
a result of sin.
Yeah, and if aging is caused by quantum tunneling, is that why? Could that have something to do with it? So, we started to think about if the sun utilizes quantum tunneling in order to shine and do everything it's supposed to do, what would that look like without quantum tunneling? Because if quantum tunneling came into existence as a process that happened after the fall, and things are going to be restored at some point, there should be something that's different about the sun later on. And we actually do have a verse, Revelation 21:23, that says, talking about the New Jerusalem, and the city had no need of the sun, neither of the moon to shine on it, in it, for the glory of God gave it light, and the Lamb is the light thereof. So that might actually be a hint that something changes when things are restored and we're in the new heaven, new earth, everything's how it should be.
Yeah.
There's no need for the sun anymore. We don't.
That's right. Well, think about it. In the beginning, he was the light anyway.
Well, and see, that's the interesting thing too, because the fall happened much later than that.
Yeah.
So you still have a sun, yet if quantum tunneling is connected to sin or the curse somehow, what about that in between time? Did the sun operate differently? Was it maybe hotter? Because if you have a hotter sun, you don't need quantum tunneling
because
for it to work.
The sun isn't hot enough to be able to, what we talked about earlier.
So maybe the sun was hotter, but, wouldn't that scorch the earth? But there is this idea that prior to the flood, that there might have been some sort of water or ice canopy around the earth.
Around the earth. It was a protection.
Yeah, and of course there's issues with that theory, just like any theory. It's just a theory, but there are things supporting it too. So maybe in that environment, you need a hotter sun for the world to operate in a livable way.
Right.
But then, of course, then there's a disconnect between the curse and the flood, which many of the leading canopy theory ideas say that canopy probably came down during the flood.
Waters came down, floods came up.
Yeah. So there would still be, well, if you have a cooler sun after, because this quantum tunneling thing after the curse or after the fall, but still a canopy, how would that work? And maybe that's why it was harder to till the ground. And, who knows? It's sure is a lot of speculation on that end. But
yeah, like we talked about this. I believe it was a nice temperate climate. And it's a very fascinating theory. And one that I suggest anybody, who's interested, look into it.
Yeah, they can find that on free on YouTube. Just put in Kent Hovind canopy theory, or he had, and this was years ago. This was before the whole prison thing, but he had I think it was like a 6-part or 7-part, basically DVD set. But he didn't copyright it. He gave it away for free, and it's on YouTube now, so people can check that out.
It's very cool.
Yeah. Well, we do have a minute and a half left, and I do want to quickly talk about, if you are interested in these topics and more, you can check out my 2 books, Quantum Creation and Cherubim Chariots. Go to skywatchtvstore.com. You can find both of those for $29.95, which actually that's a $40 value, so it's a pretty good deal. Quantum Creation is more about quantum physics for the layman, for the Christian audience. Cherubim Chariots is about extra-dimensional UFOs. It looks at the UFO phenomenon from a possible extra-dimensional source, at least some of them. So you can check that out. Also, we have the Best of, Volume 1, Best of 2016, Into the Multiverse. This is 12 episodes of the best of the first part of 2016. So from episode 1 till about episode 20-something. It's the best 12 of those on a DVD that you can watch at home. So you can check that out. Also, I have The Coming Technocalypse, which is it's an MP3 disc, basically a over 5-hour-long interview, or really collection of interviews that I did with Doug and Joe Hagman. We pooled our resources together and decided to look at emerging technology and how it likely will play a vital role in end times prophecy and really in our very near future. So check those out at skywatchtvstore.com. Well, we are just about all out of time. Again, where can people find us online?
Again, you can find us here on YouTube, youtube.com/Into the Multiverse. On Roku, if you have a Roku box, we're under the Skywatch TV channel. Someday we might actually have our own channel.
Well, they're working on it.
It's in the works, but we're still, as of right now, underneath the Skywatch TV channel. Or you can go to skywatchtv.com, and on I keep on forgetting, right-hand side, I'm sorry, pregnancy brain once again. You scroll down on the right-hand side, you will see a picture of Josh and I. If you click on it, it will take you right to the YouTube channel. Excellent. And if you have any questions or comments for the show, email me at jpeck@skywatchtv.com. Even if you have some show ideas, we'd love to hear them. We have read questions before on air, so if you have something that you would like answered on air, just let us know, and we'll be happy to consider it. So again, fascinating talk. There just never seems to be enough time for these. I can talk about quantum tunneling and quantum physics all day, but I can't distinct left from right now. Well, I think that's a good sign that it's time to sign off here. And well, we want to thank you all for watching. Thank you for joining us again into the Multiverse. And as always, take care and God bless.